Right, so let's take a look at the quadratic graphs of the other form, which is to complete the square form. So the method was done in chapter notes 1.1. Okay, so let's say we are dealt with such an expression in this form. Basically, we will go through the same process of turning point, curve, x-intercepts, y-intercepts, blah blah blah. But there's a subtle thing about the turning point of which we can actually observe from the equation itself, meaning it won't be as tedious as the case of the factorized form. So first we'll just do a calculation and just take a look at when x takes on different values, what would be the y values. Okay, so very quickly I'll fill that in. Right, so the values are 6, 1, -2, so on and so forth. You could do this very quickly on a calculator on your own. So the question here to get us started is, what is the smallest minimum value of y that I can achieve when I input an x value in? So let's take a look at the table. What is the smallest y value here? -3, right? And what x value occurs to give you that -3? Can you see that x has to be 2? And very quickly, as a pattern, we are choosing +2 because it is a direct zero pair to the -2 in the bracket. So let's apply the same thinking for these next 4 quick examples. To get the minimum or turning point of value of y, I'm going to choose the zero pair of x, which turns out to be +1. So my turning point will take on the value of +1, and I'm only going to be left with -4. Why is that so? Because 1 minus 1 gives you 0. 0 square minus 4 is -4. Here. Okay, so let's do by pattern again. What value of x am I going to choose here to get a zero pair? -4. To get 0 here, 0 square, and I'm just left with y as 5. Let's do it 2 more times. You can pause here and try it on your own. What x values are you going to choose here? And what y values will you end up with? Good. -2 here to get 0. End up with just y being 6. -6 here to just end up with -1 outside. So with that being said, can you see how easy it is to find the turning point for such graphs of a completed the square form? Okay, so let's continue on. With this. So as you can see, we're still going to follow and find out all these fellas here. But without even thinking, with the same understanding we just did, we can immediately know what the turning point is. I will choose x to be, very good, +2. And once the front part is 0, I'm just left with -9 for y. Okay, let me just erase this part to make it cleaner. Now let's continue. See, one key point already found. Let's move on. Shape. I know I'm going to get a +x² when it expands, so +x² gives you U shape. Same thing, x-intercept, I'm going to let y be 0, the opposite variable. So when y is 0, everyone, look very carefully what happens here. X minus 2 square minus 9 is equals to y, which is 0 now. I have to solve this as an equation. Similar to completing the square, right? Bring the -y, or add 9 to both sides. I'm going to have this. Square root both sides to get positive or -3. Square root 9 is 3, right? Therefore, you get 2 answers, right? Where you have x is equals to +3 or -3 plus 2. In other words, x is 3 plus 2, or x is -3 plus 2. So we get 5 or -1. So the two x-intercepts are 5 or -1. Let's proceed to sketch it. 5. 1, 2, 3, 4, 5, maybe around here, and -1 maybe around here. Okay, 2 crosses to indicate the x-intercepts. Same thing for y-intercept now. Let x be 0 and substitute it in. So y, when x is 0, you're going to get this, which gives you the value of 4 minus 9, which is -5. So put that in as well. Y is -5, maybe it's here. Okay? Okay, no. What I mean is, let's put it a bit higher, because I notice I have -9 for y here, so maybe here, yeah? Okay? -5. So line of symmetry will be in between -1 and 5, so remember the average of the two values of the x-intercepts. So -1 plus 5 divided by 2 are going to get 2. So somewhere along the line here, let me just use a different color. This is going to be 2, and this will be the line of symmetry that cuts the bowl exactly in half. Okay, so we already have 2 there, and -9, right? So -9 perhaps is going to be here. Okay, let's just mark it. This is sketch, right? So here. And now we're going to draw through to get our sketch. Going down, turning here, and this is the lowest minimum point it's going to get. Turn around, bowl up as nicely as possible, like this. Not the nicest, but as best as you can. Label it, and we're done. Moving down. Let's do this very quickly now. First thing, I'm going to do the turning point. It's the easiest. So what x am I going to choose to make that a 0 pair? Yes, +1. And once this is 0 here, don't care about the negative in front. I'm just going to be left with the +4 for y value. Okay? And then actually, if you notice, the line of symmetry will just be following from here, and it's going to be axis 1. Easy. Now, shape. Do you notice a negative here? So I am going to add up with a -x² coefficient, so N shape instead. Okay, now what's the x-intercept? Let y be 0 and solve for it. So we're going to get -x minus 1 square plus 4 equals to 0. Looks very ugly, but let's solve it. I'm just going to do it in this space here. -x minus 1 square plus 4 is 0. I'm going to shift this to the right hand side to get 4 equals to +x minus 1 squared instead. Now square both sides to get plus minus 2. And so eventually, now reflecting it a bit, so I'm going to get a +2 plus 1 or -2 plus 1. So one answer is 3, the other is -1. So answer x being 3 or -1. So let's plot it out. 1, 2, 3, 3, and maybe around -1 here. Okay. Next, y-intercept, let x be 0. Substitute it in. We're going to get -1 plus 4 is +3. So probably around here. Okay, our line of symmetry axis 1 will be here, approximately. So do a penciled dotted line here. And it's going to go up all the way till +4. So here, -1, +4. So let's sketch this. Passing through all the key points, turning around at the maximum point, the turning point, and coming back here. So an N shape as best as you can. And this is the sketch for this curve of the completed the square form. We're done.